as Ian mentioned, I'm not a salesperson, so I'll be mostly more inclined to the technology side. And I will be talking about, as Ian and myself were saying the other day, we need to answer a few basic questions because many of the people don't know what is Curvalux. So what is Curvalux? Why Curvalux was formed? Why everybody joined Curvalux? And what new thing Curvalux is doing? And how it's going to benefit for the fixed wireless access. So I will try to answer those questions. Feel free to contact me after this session. I think we can go to the next one, please. Thank you. So what is Curvalux? Curvalux is basically formed by a group, which is Airspace Internet Exchange. This group has got two companies. One is called Saturn, other is Curvalux. This group was already working for some time in satellite communication business. That is under the name of Saturn. Then a thought came up that there is a lot of synergy between the satellite communication and the terrestrial communication, and a lot of technologies which are already there. And in some of the cases, especially in the area of antenna design, like any technology, antenna design was also going through like S-curve. As the time passes, you go to a plateau. And for example, we have been seeing reflector antennas since World War II, or maybe more before that, right? Array antennas a long time. I was member of the ETSI committee for many years, and this point always came up that main drive which is coming in the wireless communication is the radio guys, is the signal processing, is the protocol, is the networking. What is new coming in the antennas? We are seeing these reflectors and these dishes for a long time, single beam antennas. And I think that was the reason that I left my last company and joined Curvalux. And I think most of us joined Curvalux because of this, because Curvalux wanted to do something different, something which has not been done in such an extensive way. And objective was to have a cross-discipline team, starting from the RFIC to the system level and the network planning. Now, everybody sitting in one room, coming from different discipline. So far, we have been working either in the radio industry or in the networks or in the operators or the antenna designers. But when all of these people are in one room, then you can imagine the synergy. Then people can think, how can we move forward? But if you want to move forward, you have to have a technology right from the silicon, from the IC till the system. As just now mentioned, how we are seeing the effects of the IC crunch and all those things. And so the team basically includes RFIC designer also, antenna designer also, RF filter designer also, system designer also, and the network planners also. And that is really a fun, which I see after a long time when we all sit together and discuss each other. And other thing is the team itself is focused to do something which is different. And the main focus is basically on the access side, wireless access side. That is the main focus. Because we all know there are different segments of access, like a backhaul or short haul or long haul or fixed wireless access, but our main focus is fixed wireless access. And objective is basically, if you see around, that we are not only using this technology for the satellite communication, but also for the terrestrial communication. And if you see this sketch, you can see the connectivity from the tower to the home, the connectivity from tower to the street furniture, and generating these hot spots. So basically, it is the full footprint which you are trying to generate. And that is what is the vision is. And that is how the systems are being developed. Next one, please. Okay, so our mission at the moment, as you know, I will not go into how many people don't have internet and all those things, but Curvalux has got a mission that we are mostly focused to have a next generation wireless access systems. And Curvalux, which is in UK, is mainly focused on terrestrial communication. Saturn in US is focused on the satellite communications. And the objective is, of course, to bring some smart solutions, something different. And I think that is the reason I would like to announce this thing also. Within the last few days, Curvalux has been shortlisted for 2 international awards, one for innovation and second is impact on the community. Because COVID has already shown that there is a community need also to provide a low-cost, efficient connectivity to those who are unconnected. And that is the main drive which is going on. So that is a big recognition. Within 2 years, the team got that has at least shortlisted against those key players which are already in the systems. For the smart solution, of course, I will talk about different challenges and different options and why the technology which I'm talking about is going to give more benefit in a minute. Next, please. Okay, so we are talking about the gigabit, right? Everybody wants high capacity, and there are different options. But we know the laws of physics are there. Range and capacity goes against each other. Range increases, capacity goes down, right? Everybody wants to increase the range, more coverage, less complexity, more and more vendors are there. Interoperability. You don't want to focus you don't want to just stick to one vendor. The solution doesn't remain scalable, and you can only go through one path. So the solution should be such which should have diverse, and you have more freedom to scale it up. Unlimited plans, operators, wireless internet service providers, sometimes they have a scalable solution, and sometimes even that vision is also not clear where you want to be after 5 years. It keeps changing with the challenges, with the technology, with the risks which are going on. Typical example is COVID. I used to live in China for a few years, very close to Wuhan, and I was trying to save myself from COVID, and I came back to Scotland because I live in Scotland. Nobody knew that everybody will be wearing masks 2 years back. When I was in Shanghai airport, and whenever I used to land, I used to say, why these people wear masks all the time? And now we all are wearing masks. They are not wearing masks. So nobody knows how the things will change. And this is what the technology needs to drive accordingly. Now, if you see what are the options to achieve gigabit. I know there are financial packages from the government, voucher scheme and all those things. And the main key point comes in the mind, I want high capacity, so many megabit per second. So the first thing which comes in the mind, use fiber. Because fiber gives you a big pipe and it can give you higher capacity. Wherever fiber is available, no doubt. I know there are many fiber lovers here, so I don't want to offend anybody. Fiber is good technology. But if fiber is not there, we all know the challenges. Cost. The cost is dependent upon the distance. Fiber deployment cost is so many pounds per kilometer, where wireless is not that type of things, right? Other thing is the access to the terrain. You have to deal with so many landlords and time to the market. So all these challenges are there where people say, oh, fiber is good, but sorry, maybe fiber is not good for me at this point of time because of these reasons. Okay, what is the other option? Use normal wireless LTE and 5G. A lot of buzzwords are coming up. Now, typical LTE site, 360-degree sector. I have been designing antennas for LTE for many years. 120-degree sectors, 3 sectors, power consumption per site, about 10 kilowatts. Data rate of a 2 kilometer, 3 kilometer, 900 megabit per second. LTE is not good. Go to 5G. Okay, 5G, I can have a 2 gigabit per second maybe. How much distance? 2 kilometers, 3 kilometers. What is the power consumption? Right? So it is good, but it has got its own limitations because I want high capacity and also good ranges also. Now, there's trillion of dollars business people are talking about for LEO, low Earth orbit satellites. Another way, provide the connectivity directly from satellite. Very good concept. And so I was reading somewhere, it is expected that about more than 100,000 satellites will be in the LEO orbits. If it goes in this direction, excellent, no towers, nothing. You will have a direct connectivity with the LEO satellites. But there is Mr. Butt there also. And where is what Mr. Butt is doing? LEO, low Earth orbit satellite. It's not like a geostationary. It means the satellite is moving. It means your CPE antenna should be tracking your satellite as it moves away. And the cost of the CPE goes high. Is that cost of CPE can be supported by thousands of people who are living near the equator where the connectivity is not there? Can they support that type of capital expenses to buy that CPE? Definitely the big question mark. So there's a drive to reduce the cost of the customer equipment. Apart from this, the other thing is, of course, as we are doing already for some time, that fixed wireless access, make user access point and put an antenna, right? And illuminate a valley, illuminate a village. Most of us have been doing it for a long time. But here, when we are doing it, what we are doing? We are using reflector antenna or array antenna. One beam illuminating it, or maybe sometime omnidirectional antennas. And now people are talking about some other technologies also. So there is a constraint from the wireless point of view also for the capacity and the range. Now the question is how to overcome the problem of capacity in wireless. How to get the gigabit in wireless. As I said, there's a lot of work has been done on the radio side, and we have heard today, definitely. But what about the antenna side? What work we have done antennas? Still we see the same reflector antennas, if not center fed, maybe the offset. Still we see the same panel. What if you open the box, what is inside? Just printed circuit board, one array, and radiating one beam, right? But if I want to increase the wireless broadband connectivity in terms of the capacity, these are the basic physics, right? We have to either increase the spectral efficiency because the spectrum is finite, and I need to get the maximum out of it in terms of the capacity, and the parameter is called spectral efficiency. How to do it? Easy approach, go to higher modulations. Okay, so I can go to the higher modulation. Work is very easy. Why everybody doesn't work on higher modulations? Why are you working on a lower comm? Work on higher comms. Problem is solved, but nobody is doing that. Why? The reason is the higher modulation increases the spectral efficiency, it increases the capacity, but it does not increase the availability of the capacity. And people are not interested in capacity, people are interested in the availability of the capacity. The dollars come from the availability of the capacity. And on what factor availability of the capacity depends? That depends upon your C/I ratio, carrier to interference ratio. Because the moment you go for higher modulation, your system gain reduces. You become more vulnerable to interference. And if you are working in an environment where there's already a lot of interference, you may not be able to use those higher modulation. So all the benefit have gone. What is the other? Increase bandwidth. Fine, use bigger channels. But you don't have that freedom all the time. Increasing bandwidth is another approach, is basically you increase the frequency. Because the bandwidth is always percentage of frequency. Higher the frequency, higher the percentage, higher the bandwidth. And that is why everybody is asking, what is the plan for 26 and 28 gigahertz? Somebody is talking about 60 and 80 gigahertz. That is another way of increasing the capacity. But as you go on higher frequencies, what happened to the atmospheric propagation losses? People ask, when 26 gigahertz will be launched by Ofcom? Another person asks, do you have the range chart of 28 gigahertz? These itself shows what is going on in our mind. We are seeing an opportunity, but we are seeing the challenges. I'm not against going to higher frequencies. Definitely we will go, but this is one path, but this is the limitation. Next one is the spatial efficiency. What is the spatial efficiency? Spatial efficiency comes from an antenna that you radiate in such a way that you get maximum out of it. What are those techniques? MIMO, single user MIMO, multi-user MIMO are basically spatial efficiency techniques. Other spatial efficiency technique is that you use the spectrum in such a way that you don't get interference. Now, other thing is, of course, increase C/I. Now, what is C? C is the carrier power. I'm talking to you. Everybody is quiet, right? Even if I whisper, you can hear to me. I don't have to transmit a lot of power because the environment is very good. But we are not, this is an ideal situation that everybody is quiet. I'm very lucky that everybody is quiet and listening to me. In real life, it doesn't happen. Everybody is speaking. Typical example, unlicensed band, 5 gigahertz. I was talking to somebody in the tea break, why don't you use 5 gigahertz? He says, no, 5 gigahertz too much noise, too much interference, everybody's shouting, right? And how people are overcoming the problem of capacity sometimes, they say, okay, bigger antenna, transmit more power, higher EIRP, but Ofcom and regulatory bodies are putting their barrier on the EIRP. So one approach is I will keep loud speaking. I will just keep raising my voice, keep increasing the size of the antenna. Or if I'm more clever, I will keep the size of the antenna small and I will increase the aperture efficiency. This is maximum people are doing at the moment, right? To get more C over I. But is it not the clever way? We all are moving towards C. We are forgetting about I. How to reduce I? Everybody will not keep quiet. So I have to do with my antenna so that it is less vulnerable to interference. And that is the main innovation where the Curvalux is moving forward. Now, how we are solving this problem? One approach is have an antenna with a very low side lobe levels, single beam, very low side lobe levels. And those of you who are in the back hall, point to point, they know there are standards from ETSI class 1, class 2, class 3, class 4. The difference is just the RPs. But if you go to 5 gigahertz license band, nobody talks about RP. People just say this is the gain of the antenna. Neither this manufacturer talk about the RP, nor the supplier, the integrator ask about the RP. As far as I'm getting this much power, that is good enough. So now, what we are trying to say, with the multi-beam antenna, you can improve the interference mitigation, first thing, increase the range, and better coverage. And I want to show you how. Okay. Now, so far, if you see, what is going on, what people are putting? People are just putting either the omnidirectional antenna, radiating in all directions, gain 9 dBi, 10 dBi, 11 dBi. And if you ask why you are getting more ranges from the omnidirectional, people say that we have increased the gain. Or our pattern is such that is more omnidirectional, which means when you move in a circle, if the power doesn't fluctuate that much. That is the beauty. People claim, as an antenna designer, I will say, if somebody asks me what best omnidirectional have you designed, I will just say higher gain and no ripples. And there's another technology people are using, which are quasi-omnidirectional, which is not omnidirectional, but we are using different panels and making it look like an omnidirectional. But omnidirectional has a limitation in terms of the gain. And you are transmitting power to everybody. Even you are telling to those people who are not interested to hear you. And you are listening to from everybody where you are not interested to hear from. So your I will always be high in omnidirectional. Other approaches move the beam sector, right? 20 degrees, 30 degrees, 60 degrees, which are generally the reflector antennas and the array antennas are doing. But again here, you can increase the C by increasing the gain of the antenna. But the interference problem will not be solved because you are listening, everybody is in the same beam. So the same thing I'm talking as on a loudspeaker. I got a flashlight and I put the light on everybody, right? So what is the problem? Problem is I can see to them and they can see to each other also, which may be causing a distraction, maybe an interference. The beauty is if I just transmit a laser beam and only we are one-to-one and they are not bothered what others are doing. And that is how can be achieved with the multi-beam antennas. So if you look at it, going from all users in one beam to putting users in different beams. So if you look on upside, you can have a sector, and in this product, just 16 beams are there, just like 16 point-to-point antennas are there, or 16 radios are there. If you do it in a conventional way, it will take a big footprint on a tower, right? The beauty is bring it in a small box so that it looks like that as if 16 antennas are there, but basically there's one antenna which is acting like a 16 antennas and radiating 16 beams in the different directions. And of course, you can use 2x2 MIMO and all those things also here by using the XPIC, transmitting vertical and transmitting horizontal, okay? And if you see over here, these 16 beams, which are shown over here, look at the side lobe level, that is also very important, and how the beams are overlapping to each other. If the beams are merged, then you will lose all the beauty of isolation between the beams. And the main objective is improve C over I so that my one beam this table, second beam, this table, third beam, this table, fourth, this table, and this table. And I'm talking to everybody without I'm talking to each other's, and I'm doing any interference. So that is the main technology which we are talking about. And this is basically achieved through phased array antennas by changing the phases. Other advantage which you see on a single beam, I've just overlapped a single beam from a reflector or from an array to the single beam, to the multi-beam. If you see a beam has got not a flat top, it tapers down. So what happens? The people who are living on the edges of the sector, they don't get that much power. Their power suddenly drops down because the beam shape is like this. So these people are getting less power, these people are getting more power. But if I go a flat beam, like this one, so if you look at it on this one, this will look like a flat, same EIRP everywhere. So my coverage, my heat map will be more uniform. In this way, I can improve the coverage also. And since I am narrowing down the beam, I can achieve higher gain also. So this is a typical example, use cases, 60-degree beams with the different CPE antennas. What we are achieving, about 16 dBi, 2 kilometers, 10 kilometers, 2 by 2 MIMOs, 7 to 20 degrees, 16 beams. We are doing with Wi-Fi 5, which is 2 gigabit per second per sector, and with Wi-Fi 6, which the trials are going on now in US, we are achieving about 5 gigabit per second per sector. We are moving to 6E also soon when, of course, things will be better. Next, please. I will not take much time here. I was basically an R&D designer, and then I moved to the commercial side. So I was always living in the world of dBs. But when I went to the commercial side, people asked me, don't talk dBs, talk in pounds and dollars, right? So I made a currency converter. The currency converter is reduce interference, which means reduce dBs, so many dBs down. And you can do it with your wisdom or something else also, right? On your planning tool. Do this exercise, use the radiation pattern, reduce the pattern envelope in terms of dBs, put it dB down, your COI will become higher. You can use higher modulation, system gain will higher. Calculate how much LT capacity you have achieved more. And you can straightaway find out what will be the benefit in terms of revenue and the capacities. So dB to dollar or dB to pound calculation can be done using any link learning tool. This is a case study which has been done, which is basically showing that a Curvalux and a typical system. So within a Curvalux 60-degree sector, you can have about 1,000 to 500 users, whereas others are claiming about 90-degree sector, about 250, which means 160, 2 gigabit per second against 1 gigabit per second. So in other words, just moving from a single beam to multi-beam, you can achieve 100% increase in the capacity. And definitely, depending upon your tariffs, you will have more revenue. The trials have already been going on. Some trials have already been completed in different countries. And we are seeing a lot of interest at the moment on the multi-beam antenna technology, the phased array technology which we are bringing. This is the proof of concept going on in USA, where we are seeing about 540 megabit per second downlink up in 2 kilometers with a Wi-Fi 6, 16 dBi CPE antenna. Next, please. This is rollout is going on in Philippines. Already many sites have been deployed. 45 additional sites are across the Philippines now, and next year about more than 100 sites will be deployed. And this, they wanted to achieve about 50 megabit per second. This is for Globe. In a 3 beams, about 70 customers. Hardening has been done. 50 megabit per second was a cap put by Globe. Otherwise, it would have gone higher also. Okay, closing it down. 28 gigahertz. Our next product, which is likely to be launched in Q1 2022, you have heard a lot about software-defined radios. We will be talking about software-defined antenna. Software-defined antenna will be an antenna which will be working on these frequencies, and it will have all the features. Whether you can do dynamic beam shaping, you can do the load sharing, you can change the radiation patterns dynamically. And that is why we need our own RFIC, we need our own chip, and that is where we are working for now. So this is the technology which we think will be a game changer with the addition of 26 to 30 gigahertz, 29 gigahertz 5G new radio frequencies, and also for 37, 38, and LMDS frequencies. because some markets are looking for those also. With this, if you have any question, feel free to contact me or call our salesperson. They will let you know. Thank you very much.